Thanks for having me. I'm going to talk about pull request size and how it's the most important indicator of the dev pipeline health. I'll quickly introduce myself. My name is Ori Keren. I started my career as a developer. I wrote my first program in BASIC in 1987, and every presentation I give, I try to do an homage for the computer I wrote my first BASIC program on. This is a Sinclair Spectrum, 48K RAM. This is the level of RAM they had the days. But I was a developer for a couple of companies, a team lead, did twice a role of head of engineering, and decided, or in startups that were acquired and were successful, which was great. Was lucky enough to go through two successful journeys. And in 2019, I started LinearB, which is basically a software delivery intelligence platform. It helps detect bottlenecks and improve the day-to-day work of the engineering organizations. When we started, there was no awareness almost to engineering metrics. The academic research just started, but we're now in a great, I think, in a great era where everybody wants to talk about engineering metrics. One of the other things we did in LinearB, we started a podcast and a network called Dev Interrupted, where it's now one of the most popular podcasts where engineering leaders come and talk about what they measure and what's important for their culture. And as you can see, there's great leaders here from GitLab, GitHub, Netflix, Datadog, all some very cool companies that want to share their insights. So it's a different time where everybody wants to talk about engineering metrics. I want to start by defining what's a healthy development pipeline. How does a healthy development pipeline looks like? One of the best research, work that was done in this field was done by the DORA group, DevOps Research and Assessment. I think a lot of us know by now, are familiar with the work of DORA. They define the key metrics that you should track in order to detect if you're on the right track as an engineering and a DevOps org. To 4 metrics. 2 of them are kind of in the speed area or efficiency, and 2 in quality. So the 2 that relates to the speed or efficiency is cycle time, or sometimes it's a lead time for changes. Basically, how much time it takes from when the developer commits code to until it's deployed. And all the phases that it needs to go through that. Deployment frequency is another one around speed or efficiency. How often are we deploying code to the production environment, and how often value hits the customers? We move to the quality area. It's really interesting because quality has been traditionally, or legacy quality was how many bugs we have, things around the code. But we live in an era where tracking the quality of your releases and your deploys is not less important. So the 2 key metrics that this DORA group are talking about around deploys and around releases are CFR, or change failure rate, which basically means any of my releases failed. I had to do a rollback, right? Because there was an outage or some downgrade in one of the services. So that's one. The second one is mean time to restore. So let's say something bad happened, how much time it takes me to restore and get back to normal. Both of these are really important quality metrics, and that's how you can look at a healthy pipeline. We sometimes in LinearB to kind of extend a little bit the definition. One of the topics that we think is a major player in the development pipeline health is the pull request. So this is why we're looking also on things like the review time, how much time it took to review that pull request, and also review depth, which is some sort of quality, but quality to the process, right? What's the density of the review we're doing, and how much coverage we're getting there. Now I want to take you to a research that we did. So in LinearB, we have data from thousands of teams, and we have some cool insights that we want to share from our lab. So I want to start with a very, very basic definition of what we call the pull request paradox. I'm sure everybody here know exactly what I mean, but it's really important to repeat it and say so it's all clear in our heads. Here's the problem in very simple words. If I'm a developer, I'm working on something, I feel that I just solved a really important problem. I want a review now. That's always the case. I want to push this to production as fast as I can. And by the way, it's a good instinct. Fresh code that hits production is a good thing. It means that, if there's a problem, it's still fresh in my head. I'll still know how to fix it. But usually I hit a roadblock because my peers that I need the help from them to review are kind of working and solving yet another very important problem right now. So a lot of time, this is what's happening. Next day arrives, my peer is now free, like, hey, I have some questions around your PR. My mind is already in the next task. So all this process is very, very unsynchronized, which is a good thing. It doesn't have to be synchronized, but we need a little bit more coordination. And I won't dive into the math models around it, but if you want to look into the queue theory and a lot of like how you balance like free time versus like busy time, it can help like optimize that problem. Now, here's the amazing thing. If we look at the cycle time, which is basically from when code is being written until it's, like we said, till it's in the hands of customers, you would imagine that most of the time would go to coding or building something or to the actual deployment process that might take, some time. But here's the amazing piece of data that we were able to track. If you look at the average like cycle time or lead time for changes, it's around 6 days and 4 hours. So 6.5 days, 6.5. But if you look at how much time out of that, like pull requests took like the time slot, it's almost 5 days, 4 days and 10 hours. So 2/3 of the cycle time are because everything around pull requests, right? So picking up a pull request to start reviewing it, doing the review process, right? There's sometimes a lot of back and forth. So 2/3 out of the cycle time are around pull requests. It's very dramatic. This is where if we can automate some stuff and optimize that part, we can achieve a lot. Our researchers and analysts did even more than that. They looked into more and more data. You can see the numbers here. It's close to 1 million pull requests and 4 million comments, etc. A lot of like broad like range of data, big data set. And they found out that most of the pull requests just sit idle for half of their lifespan. So half of the time nobody's doing nothing with them. And if you go to the 33% of the PRs, like the bigger ones, it's almost 80% of their lifespan. They're just sitting there and nobody is doing something with them. So it's a lot of idle time, and we'll talk now on why idle time is bad or why is it caused even first, right? So when our analysts kind of like dig deeper into the data, they discovered 2 types of idle time. The first one is transition time. It's really easy to understand, right? We have all been there. I'm issuing a pull request, now I need to wait to a busy resource, not necessarily more busy than me, but in the context of what I'm working now, I'm in the zone. I want to push it, and somebody else is busy because they're working on something else. So all of these transitions, why it happens, so all these end-offs, they create delays. Not all the pull requests are treated equally at the first glance. If I'm a reviewer and I'm getting like 10 requests to review something, I don't know what's short, what's long, what can I resolve in 1 minute, what do I need to allocate an hour to resolve? And all of these transitions, they hurt productivity because they increase the cognitive load. It takes me a lot of time to reload the code into my head when I'm reading it. There's a lot of context switches. So we established the transition time every time we need to switch ends. It hurts our productivity as developers. Now, the second type of idle time It's what we call destruction time. And this is not me that I need to like ask somebody to review. I was already asked to review something, right? But it's a long pull request. It's probably a big one. And then we go into the area of destruction time. What would usually happen to me, the human brain can read, there's all kind of theories around it, but if my reading task is more than 20, 30 minutes, it's going to be hard to read it once. I'll probably do a lot of like reorientation and reload. It takes 10 to 15 minutes to get to this cognitive state where I kind of understand the flow of the code. And now somebody comes in and they interrupt me. They say something to me. That's it. It's going to take me the same 15 minutes to go back to the same state I was before. So I guess the point that I'm trying to make here, if you have large pull requests and you're asking your peer to review it, there's going to be a lot of interruptions. There's going to be a lot of like very long tasks. I would need energy breaks if I'm the reader of that code. And again, there's a lot of reorientation. I read something, I kind of understand how the code flows. Now I need a break. It's going to take me 10 or 15 minutes that I already invested to re-understand where I am. It's destructive to productivity. So that's the second type of idle time that exists. Now, here is an amazing piece of data. I always say when I give this talk track, if you want to take something from this presentation, take this chart and take like a mental picture of this. This is what's happened. This is very important. If I'm going to ask somebody to review my PR and something, either me or some system will say, hey, it's going to take you less than 2 minutes to review it, or even 2 to 7 minutes, or up to 15 minutes, it's still going to be picked up in the first 30 minutes. It's dramatic. Again, by the way, even if I lie, which I won't do it, but even if just like some header would say, hey, this is short, you can read it and comment it like super fast, still the reviewer will pick it up fast. They will take the context switch and they will do it. So, and as developers, we know we have a lot of times where we want like this short break from what we're doing. And if now in this short break, I have 5 minutes and I know I have a task to review something that I can fit in these 5 minutes, that's a very, very, very dramatic impact on the productivity of us as a team. PRs under 50 minutes review time get picked up 20x faster by the peers if they have this type of information in front of them. So now I'm getting to the point that pull request size has a cascading effect on our pipeline. And what we want to do is we want to reduce the pull request size to speed up the cycle time. You can see here an example. If it was a pull request and we're already it took us 2 or more than 2 days to code it, it's probably like something big. First of all, pickup time will be long. Like people will see it, they will say, okay, this is a long one, push it to the end of the day. It's not like a 2 or 3 or 5 minute thing that I can take and help somebody now. I already know it's a 30 and more minutes. I'm going to schedule. I need to allocate time. Usually it's going to go back to the end of the queue. Then the review will be long because, like I told you, there's reorientation, there's back and forth. So it's kind of like we're already not setting ourselves up for success when we have like a big pull request. It also affects the review depth or the review density because there's like this cliff, this like inflection point where if a PR is too big, you can kind of see if a PR like is small, people will give a bunch of comments, and then it will grow a little bit, people still give comments. What's happening after the PR grows into like, it's 1,000 changes or something that it's really, really hard to digest, you know what you will get. People will just look around and say, either comment on like a syntax error that they found or say, hey, it looks good to me. We all know that. So it's also about the quality, right? When we have big pull requests, the review depth will go down, which is it will hurt our quality. There's a research that says that good reviews, the ones that are like on small PRs that are being done fast, are finding 65 to 70% of the bugs. It's almost like the cheapest form of quality you can apply. Reducing pull request size will also increase the deployment frequency, which we saw it's like a DORA metrics that we want to optimize for. It will also help us improve the change failure rate and the mean time to restore, because like we said, small pull requests will improve the quality. It will get better reviews. At the end of the day, it will make less release fail. It will also, once a release failed, because it happens every now and then, it's going to be easy to restore from that, because it's not a big release with like tons of content. It's small explosions that we usually can recover fast from. So again, think about pull request size affecting all of these DORA metrics that we all think are very, very important. So this is why we keep going back to the point that pull request size is almost like can make effect on all of these metrics, and if we can improve that, it's going to do great things for us.
Hi, we are Eficode, and we organize the DevOps Conference. We think that the modern software development is about creating value as sustainably as possible by minimizing waste and risks. If you think the same, we'd love to speak to you and help you make it real. You can find us at eficode.com. The links are in the description, and have a great time with the DevOps Conference talks.
So what are the tips for reducing pull request size? First of all, well, it sounds simple, but it is. We need to break work into tasks that can be completed in a single sitting. So like, if I'm seeing it's too big of a PR, me as the person who's like the issuer of the PR, can take more work on myself, because remember, there's busy resources. And in the context of this work, I'm not the busy resource. I can split it into two PRs. If I saw this refactor in the area that I'm touching, we're always tempting to do this refactor, which is good. It's a good motivation. It's a good intuition. But we need to take it in a separate pull request. Don't pull them into your big pull request, because what you just did now, you lower the quality. Nobody will review all the code of the refactor. And the other thing we can do, we can establish work agreements with our team. So for example, we say, hey, maybe max pull request size is 200. It's hard to get to that goal. But if we hit 80% of the time we hit that goal, it's still like a very good place or something to aspire for. Now, in the broader picture, small pull request size will help you to promote your PR. Basically, what you want to do is move things fast through your cycle time. We almost think about it in LinearB like when you have a PR, it's almost like you need to sell it, because you want reviewers to buy it and take it like faster. There are other aspects that impact their motivation to take it fast. So we talked about size, but I just want to kind of like broader the scope a little bit. There's other stuff that will help reviewers take it fast. Like, for example, if we say, what's the related issue, right? What's the business context that we're working on it? If we kind of say, hey, what's the estimated review time? Even if we estimate, it's going to take you 3 to 5 minutes to review it. It's going to be more tempting to the buyer, like to take the PR earlier. So the point in this slide is, if we think about this space like this a little bit, and we understand that we need to promote our PRs and kind of wrap them in a nice package, then there's a better chances that somebody will take them faster. One of the other tips that I can give you, try to finish the important PRs in the same day. And the way to do it is, like, if you look here, sometimes you have PR, it's late at night. If you open the wait and you open it in the morning, there's more chances that people will take it. If you insist to find a reviewer within the first hour, and of course it's small, it has tests, it's written nicely, you kind of like said, hey, where you should start reading it, you will find a reviewer within 1 hour, which will help you like to get the PR merged in the same day. And then there's another thing you can make. If I'm the issuer and somebody is now reviewing my pull request, what I want to do is try to be very responsive. I have the motivation like to push it, right? We are like, the reviewers sometimes, yeah, they're doing other things. But once they gave us our comments, I want to jump and try to react to that as fast as possible. And as fast as possible sometimes mean we know that usually we like to keep these processes async, right? So especially reviewers, they don't want like to make this process like a synchronized process. But there are cases where if both sides say, hey, let's make this like an interactive and take the context switch and make this a synchronized process, and we need to identify when are the right cases to do that, it will actually save both sides a lot of time. Because a lot of the times it's very basic questions. Before I read this, I need to understand what you were trying to do here. And if we will respond fast and maybe escalate into like, hey, let's do a pairing session, like and talk about the things fast, then I think some of the PRs can go much faster. I'll go quickly on how us LinearB can help with this. So we can benchmark, of course, all of the cycle time. We can help you set work agreements on, the size of the pull request you want to have, how fast we want somebody to pick them up, and it can vary from one team to another. There's a lot of variables here. So, tweaking those and getting to the right work agreements is really important. So that's one thing. The other thing that we're really proud of that we can help is like we give every developer a bot that helps them arrange their work. Hey, like this review will take you 2 minutes. This review will take you maybe 30 minutes. So I can choose. If I know I have a meeting in 5 minutes, I can know what type of work I need to take first. We're gonna this area continue to be to develop. It's available on Slack and Microsoft Teams, and developers engage with it a lot because it's not coming from a manager type perspective. Hey, CycleTime needs to improve. It just helps me push my PRs faster and get reaction faster, so it's cool. And as you can see, there's a case study on the dramatic effect that you can have once you set those work agreements and once you deploy it. For managers, cycle time is dropping from areas of like 10 and 11 and 12 days to the areas of 2 days. And it's amazing because it's being done with a grassroots adoption and not with a manager coming and saying, hey, this is what we need to do. One other thing that we can do, and this is something new and cool that we released, if you don't want to go all in and try the LinearB solution, there's a free Chrome extension that we released that helps with those things exactly. You just like download it, you click, and it will tell you your estimated review time. You can take a link and paste it in your Slack or Microsoft Teams, or even send it in email, and it will kind of like do the things that we just said. It will tell your reviewers, hey, this is how much time it will take you to review. And now, or you can even add like a small Giphy, like saying please or pretty please or whatever. There's all funny stuff that's going on when people are using it. And again, it comes to serve the same goal. I want to promote my PR so it's appealing to others, and it's short and it's going to be easy to review, and then they will take and review it faster. So I think almost out of time, but I think we have like maybe 2 or 3 minutes to questions. I don't know if we do. Let's see if we do.
Yeah, we do have time for a few questions, and we have had very active chat. Thank you for that. And there are also a few questions that you actually also answered during your presentation here. But Thomas is asking, can you recommend a good set of minimum guidelines for reviewing a pull request? Or if you don't have a good set of minimum guidelines yet, do you have something to start with?
So I'm trying to understand, are we talking about what's this like reasonable sizes and something like that? What's those guidelines? If that's the question, what we've seen when we're looking at data, it all depends on where people are, right? So the first thing is to understand your baseline, because it's not one company versus another company. It's more where we are now. So I know when our team started to use our tool, there were like in PRs there were 700 changes each on average, the good numbers are to get to below 300 changes in each PR on average, right? And set the goals there. But we always recommend, and our system always recommends, like, jump to the next segment. There's like, don't try to go from 700 to 200, go in stages. So those are like our recommendations. And I'm a true believer in pickup time. I will try to make sure that PRs are being picked up in the same day. If you set this goal and you invest in education around that, that's a very important thing like to get to.
Right.
Yeah,
Actually, related to this, have you noticed that team size would have any effect on the pickup time of tasks? Because you then get more deeper social dynamics within a group of people.
Yeah, definitely. Well, we've seen a couple of years, definitely, but well, so it's also important to open it up and not just say, hey, team leaders and tech leaders are the only one who is reviewing, especially if you're a small team. Like I say, there's 3 people, everybody is like building, right? And how much I'm free, like to take it, you need to take my busy time and divide it by my idle time. So if I'm like free 10% of the time, it's going to take me 9 hours or something like that just to be. So I would say definitely there's an impact on the size of the team. So sometimes you will need like cross teams, etc., like to review. My one recommendation is try to open it up and train more people to review and not just keep it for a minimal group. But there is an impact to the size of the team, definitely.
All right.
Yeah, Matthias was probably asking, because I'm not sure if you heard it, Ori, but he's going to go through this with his team later on, this presentation of yours.
That's great.
Yeah, just if we can find some insights, see if we can do something for our pull request sizes.
That's right. Again, I truly believe that if the pull request size is improving, it's almost like everything will improve. Your cycle time, your metrics, your quality. I'm a true believer in that.
Yeah, and you provided very comprehensible steps towards reducing the pull request size.
Great.
All right. I think that was for the questions we had at this point in time. So I guess thank you, Ori, very much for your enlightening presentation.
Thank you very much.